Hello everyone, welcome back to my YouTube channel. So today we will discuss something related to beam. Okay, as we know that beam is an integrated part of our building. First of all, whatever the distribution of the components are there in frame structure, distribution of load, how we can say the load will be distributed to from slab to beam, beam to column, column to footing, and footing to hard strata, etc. So in which your beam is going to play a very important role. So today we are going to discuss elaborately what is beam, what are the types of beam, what is the method to you can say calculate the or design the beam. So these things we are going to discuss in today's session. So basically this is the session which will be very much important according to curriculum point of view as well. If you are appearing for the engineering, so you can take help of this video to solve your numericals or to solve some questions regarding this. Okay, so the very first point is, what is beam? A beam is an you can say horizontal, or it can be a sloping structural element to resist the load of the structure. So that is what is the first part. Second is, the main function of the beam is designed to resist the external or internal load such as walls, slab, floors of the buildings, and distribute that load to the foundation through the column. Okay, so that what already I have told you. And then the third is, the horizontal beam carries any transverse load or vertical load, and the sloping beams carry both transverse and axial load. Okay. Okay, so next is your what is the method to design the beam? The method already you know that first of all, the method which we are going to use is limit state method of design. There are too many methods, that is working stress method is also one of them, but we will discuss limit state method in today's session. The object of the design is based upon limit state concept, which means you can imagine what will be the limit. uh, Above that limit we cannot reach, right? So already you know, suppose bending moment of the beam is coming across 94 kilonewton meter. So it is the limit above which we cannot go. So if your beam is below that, or if your beam is reaching below that to the bending moment, that is, it is coming like 90 or 84 or 85, something like that, so it is okay. So this is the simple example which you can take to detail in so that to elaborate in a detailed manner what is the limit state. Okay, so the object is very clear. So you can read these things in elaborate manner, because already in a short term I have explained it to you. Okay, so it should be also be able to maintain the required structural integrity during the because IS code has already decided some limits, and they have given you the formulas in which you are going to put the values, and from that values, if something is coming, so that value should not exceed it. Okay, so whatever the calculated things are there, that calculated things, it means what you have assumed for your structure. Okay, so now the third part for this particular is the most important aspect of the limit state which must be examined is flexure, compression, shear, and torsion. These are the four elaborate things which we need to discuss, which will definitely discuss in our coming sessions. Okay, so this state corresponds to the maximum load carrying capacity in short term. Okay, whatever the things are there. Now you can see what is compression. Compression, it means if the load is coming from both the side and it is compressing something, it means compression. Tension, it means you are stretching something. Okay, so you can see bending, it means you can see some load is coming and your structure is going to bend in an arc shape. Torsion, it means it is giving you the twisting moment. Shearing, you can assume that if something is on a continuous way, the movement is happening, the shearing is happening. So you can see that shearing is there. So the type of stresses are, I have explained it in a very simplest manner. Now, what is limit state? What are the types of limit state? So the type of limit states for a collapse and for serviceability, these are different. For collapse or failure, you should consider flexural, compression, shear, and torsion. And for serviceability, you must consider deflection, cracking, vibration, fire resistance, etc. Okay. Now, what are the types of beams? So the four basic types of beams are singly reinforced beam, doubly reinforced beam, or you can say singly reinforced, doubly reinforced. Fusion means flange beams and continuous beam. These are the four types. But basically, these two we need to discuss elaborately as a part of engineering. Now, what is singly reinforced beam? So the beam reinforced only in tension zone, we call it as a singly reinforced beam. If the beam is reinforced on both the sides, we call it as a doubly reinforced beam. So in singly reinforced beam, the final bending moment and stress because of them are carried by the reinforcement, while this compression is carried by the concrete. Compression will be carried by concrete and tension will be carried by steel, in a simple manner. But it is not possible to provide reinforcement only in the tension zone because we need to tie the stirrups. Okay. Two rebars or we can say therefore two rebars or holding bars are used in compression zone to tie the stirrups. So you can see that this is what is the diagram. Okay, you need to draw this diagram while appearing for the exam. So it will be helpful for you. Simply, you can draw in this manner. Now, doubly reinforced beam, as I have told you that if the steel is provided both in tension and compression zone, we call it as a reinforced beam. Okay. And lastly, this is what is the diagram. Okay. So in today's session, we have elaborately discussed the chapter beam. I hope this was helpful for you. Stay tuned, guys. Again, I'll bring many more topics helpful for you. Okay. So thank you. And please like, share, and subscribe my channel.